Let's start with number 3. And that looks like y equals x minus 3 squared. All right, remember that we're going to find the vertex for vertex form by looking at h and k. Let me just make some room here. The vertex is going to be at this point, h comma k. So let's make some sense of that. Here we have h is the guy in here with x, so x minus h. X minus h. And it looks just like this with a subtraction, so this must be the x value, 3. And then k. K is going to be the y value. What goes here? Well, first we have to know what we're adding here, and that would be nothing. There's nothing out here to add, so the y value would be 0. So let's go ahead and graph the vertex. 1, 2, 3, comma 0. So right there on the x-axis. Part of the directions here say that they want us to label the vertex and the axis of symmetry, so we might as well draw the axis of symmetry and then we'll label it. Okay, so here's our vertex. It's at 3, comma 0. Here's our axis of symmetry. It is a vertical line. Vertical lines are x equals equations, right? Because x is always the same on this vertical line. It's always 3. X equals 3 is the line of symmetry. We are supposed to finish graphing this, so to make that pretty simple, let's, well, first, we also know in vertex form, whatever a is, the number that's multiplied on the outside of the parentheses, if it's positive, it opens up, and if it's negative, it opens down. We look at here, what's multiplied on the outside of the parentheses? A 1, a positive 1. So it's going to open up. All right, but let's put just 2 more points there to give us an idea of kind of how wide it is. So let's do a table of values. I like to put 0 in there, makes things pretty simple. Because when you put 0 in here, 0 minus 3, so that's left in here is a negative 3. Negative 3 squared is 9. So that's a 9, so that's it. 0. Put a 0 in for x and you get out a 9. 1, 4, 5, 6, 7, 8, 9. Okay, so 0, comma 9 is on there. Also, since parabolas are symmetrical, if we go 3 this direction from the line of symmetry, we're going to go up 9, and if we go 3 in this direction, we should also go up 9 because they're symmetrical. Okay. So through these 2 points is what we should be sure to make the parabola go through. All right, so there we go. There's our first example of how to graph in vertex form. Let's do number 5. F of x equals negative x plus 3 squared plus 5. So we're going to find the vertex, and that will be found with h and k. So here's where we're going to find h, and here's where we're going to find k. K is the easy part. K is always just whatever this number is out here, whether it's positive or negative. The thing about h that trips people up is it's the number that is being subtracted. Okay? And most of the time people will just put 3 here. But we're not subtracting a 3. We're adding a 3. So what are we subtracting? How do we write this as a subtraction problem? So let's work off of this. We know we need to be subtracting h. So what would h have to be so that the end result is the same as adding 3? What if we subtract a negative 3? If we subtract a negative 3, it's the same as adding 3. So h is a negative 3. Right? So, or you could look at it as the opposite of whatever you see here. So if it's a positive 3, h is going to be a negative 3. If it's a negative 3, h is going to be a positive 3. Right. So there's our vertex. Negative 3, 5. There we go. There's our vertex. We'll go ahead and label it. And the line of symmetry goes straight vertically through the vertex. All right, vertical lines have x equals as their equation. X equals, well, x is always the same. It is -3. No matter what y is, x is always -3 on this line. Okay, and now we need to know which way does it open. If a is positive, it opens up. If it's negative, it opens down. The number that's out in front here is a -1. So negative multiple outside the parentheses means it's going to open down. It's going to open really wide like this or really narrow like that. Let's find out by putting a couple of values in there. Let's put in a 0. We have 0 plus 3 is going to be 3. 3 squared is going to be 9. Times -1 is -9. So now we have 3 squared is 9, and then we make it negative, so -9 plus 5 is going to make it a -4. Right, so if we put in a 0 for x, we wind up getting a -4 for y. So we just want to make sure we make our parabola go through there. And using that line of symmetry, we have put that point there at 3 from the 3 to the right of the line of symmetry, and 3 to the left of the line of symmetry. We should also put a point at y equals -4. Okay, and one last example, number 6. Let's see, y equals 3 times x minus 7 squared minus 1. All right, so we need to find the vertex. The vertex is going to be whatever number is subtracted from x. That's a 7. Positive 7 is subtracted from x. And then the y value, the k value, is -1. We're going to plot our vertex now at 7, -1. Okay. Now does it open up or does it open down? It opens up because this guy out in front is positive, so it's going to open this way. Now, I have been putting 0 in for x, but 0 is pretty far away from our vertex. And so if we're going to come all the way over here, probably it's going to be really high up on the y-axis. That's my only point. So maybe we should choose like 5. Let's choose 5. So for x, we'll put in 5. 5 minus 7 is -2. -2 squared is 4. 4 times 3 is 12. And 12 minus 1 is 11. That's already pretty big. So it's a good thing we didn't choose 0. So 1, 2, 3, 4, 5, 6, 10, 11. Okay, and that point is at 5, comma 11. Right about there. All right, and our line of symmetry is going to tell us how to easily find another point. Our vertex is at 7, -1, and our line of symmetry is at x equals 7. And since we have a point just 2 to the left of the line of symmetry, we go up to 11. 2 to the right of the line of symmetry, we should also go up 11 because they're symmetrical. Right, and there you go. So we have this very steep, tall parabola that opens up. Okay, so in vertex form we have graphed each of these. I'd like to take a second and look at intuitively why can we just grab that information out of there, and why do we know that this is the x part of the vertex and that this is the y? You may notice that in each of these cases, just look at the x part. So I'm going to grab red here. So just look at this x part. What happens when you take this x value and you put it into the parentheses here. So you take 3, put it in there. For this one, you put -3 in there. For this one, you put 7 in there. You put 3 into the x value here. 3 minus 3 is 0, so the parentheses is 0. You put -3 into these parentheses, you get 0. You put 7 in here, you get 0. So that's interesting. Each time that we put the x part of the vertex in, we get 0 in these parentheses. And that should make sense that that would be tied to the vertex, because the vertex is the either absolute minimum or absolute maximum value, just depending on which way the parabola opens. So, why is that important? Just because this is 0. Well, then that means that this is the only thing giving us output. If this becomes 0, then all that's left is 0 here. If this whole thing, if this parentheses is 0, you square 0, you get 0. 0 times -1 is 0. So all of this, everything except for this +5 is gone, right? It's become 0. So all that's left is 5. And in this case, you put in a 7, you get 0 for all this, and you're left with -1. So why is that important? Why would that mean that that has anything to do with the vertex? It could just be just a coincidence. But if you can make this go to 0, then it's making no contribution to the output. It's doing nothing to the output, and all that's left is this. Once this starts to come into play, once this doesn't get eliminated, then it's going to start to give something to the output of this function. And either this thing is going to be adding to this output, little by little, or it's going to be taking away from it. That all depends on if this is a negative or if this is a positive, and in this case it's a positive as well. So once this isn't completely eliminated, once it actually contributes to the output, in this case it's going to be taking away something from 5. It's going to be the y value is going to be less and less and less and less and less, more and more and more and less than 5. So 5 would be the absolute biggest value we could find, and so that would be the y value of our vertex. And for this example, 0 would be the absolute smallest value we could find, because as this starts to not be eliminated and actually contribute to the output, it's going to give us values that are a little bit bigger, a little bit bigger, a little bit bigger than 0. We're going to add on to the output just a little by little. Over here, -1 would be the smallest value we could find, because it's going to, since this is a positive out here, a +3, whatever we put in here is going to be, you're going to square something, it's going to be positive, and then multiply it by +3, it'll be positive. So we're going to add a little bit to -1, a little bit more, a little bit more. We're just going to get further and further and further away from 1. Just going to keep going up and up and up and up. So whatever causes this piece to go to 0 is going to be either the smallest or the largest value of y. I know that may not make a lot of sense or complete sense. Should make some sense though. But in any case, you now have 3 examples. You can definitely do it. You can find the vertex, you can find the line of symmetry, you can find a couple points to make sure you can draw through them and get the relative narrowness or wideness of the parabola correct. Okay. So that is vertex form. Now, I would love it if that explanation of the y for the vertex form made complete sense to you and there was absolutely no confusion, but completely understandable if there was. The good news is vertex form is going to be less important as we move on. What's going to be more important is what we're about to look at, which is intercept form. Okay, so we'll bring this back from the intro video. Y equals possibly a number times, possibly this scalar multiple here, x minus p times x minus q. Alright, so it's going to be written like that. And what we know from this is we're going to find 2 points automatically, p, 0, and q, 0. These are what we call x-intercepts. Okay, x-intercepts because that you're going to see that's where they cross the x-axis. The y value is 0, and where the y value is 0, you're on the x-axis. And so that's where we'll start. We'll just start by looking at that. Where do we find these x-intercepts? Okay, so we will start number 13. Y equals x plus 3 times x minus 3. All right. So keep in mind the form that this is in x minus p and x minus q. And we'll find x-intercepts at p and q. But first, p and q have to be subtracted from x. This is very similar to the issue we had in vertex form, where we have to say what's being subtracted from x, because that's the form it needs to be in. And we're subtracting a negative 3 here. Okay? So in this case, p is negative 3, q is positive 3, right? X subtract 3. So we're going to find x-intercepts at negative 3 comma 0 and 3, positive 3 comma 0. All right, we'll graph this at 1, 2, 3 comma 0 and negative 3 comma 0. So those are 2 points on this graph. And without really having to involve the quote formula that is, kind of the next step here, we know that this parabola is symmetrical, that it goes through these 2 points. So whether it comes down like this or goes up like this, we know it's going to go through these 2 points. And it could be a lot taller and do this, or it could be a lot taller and open up. Whatever it's doing, it's going to go through those 2 points, and we can see in all those scenarios the vertex is going to be right in between them. And since these are equally spaced away from the y-axis, the vertex is going to be somewhere on the y-axis, so that's where our line of symmetry is going to be. Okay. So the vertex is going to be at 0 something. The x value is going to be 0. How do we figure out what that's going to be? Well, we're just going to put 0 into the equation. Put 0 in for x and see what we get out for y. So if we put in a 0 for x, let's see, maybe we could just create a table of values here. We're going to put in 0. That means that we're going to take 0, add 3, then take 0, and subtract 3, and multiply those 2 things together. So you get 3 times negative 3, and we have negative 9. So again, this is our vertex. It's going to be at 0 comma negative 9. There's our vertex. And that makes things pretty simple to graph. There we go. So our vertex we could label at 0 comma negative 9, that's part of the instructions, and the line of symmetry at x equals 0. Okay. Let's do number 20. F of x equals negative 2 times x minus 3 times x plus 4. All right. We're going to find 2 x-intercepts based on these 2 sets of parentheses, x minus 3, right? X minus p. So the first one, the first x-intercept is at 3 comma 0 because we're subtracting 3. But here, we need to make sense of this. What's being subtracted here? X minus what? X minus negative 4. Minus a negative 4 is the same as plus 4. So we can see that q will be negative 4. So we'll have a x-intercept at negative 4 comma 0. Right. So 1, 2, 3, 0. 1, 2, 3, 4 comma 0. Okay, great. So we found a couple of x-intercepts. It's quite useful. And then we need to find out where is the vertex. Where is the line of symmetry? So where is that middle line? Where's that line of symmetry for this vertex? You can probably look at it and just say, well, it's right in the middle, so it must be right here. So you know where it is. but a more mathematical approach, scientific approach that works every time. We're just going to take this q value and we will add this p value, 3, okay, and divide it by 2. It's like finding the average between these two numbers, the number that's right in between these two. So negative 4 plus 3, that'll be negative 1 over 2, negative 1/2. So right there. Negative 1/2 is where our line of symmetry will be. And now we need to find the vertex. In order to find the vertex, we need to plug this x value into the function and find where the y value is. So x and y. X is negative 1/2. So what's y going to be? Here, let's, I would use the calculator here. Why not? So it just makes it a little quicker. So this will be negative 2 times x minus 3 times x plus 4. Okay, we want to plug in 1/2, so we'll go to the table, plug in 1/2. There we go, 22.5. Well, that's pretty high up there, but that is what it is. 22.5 is what y will be. So we will just make this into 22.5 just so that we have enough room. Just force it to be that. Because all we need to do now is connect the dots. Okay. Kind of rough, but there it is. Okay, so now for the reason why this works. Why can we just look at what's in these parentheses and just kind of like pull out the opposites of these numbers and get y-intercepts, or sorry, x-intercepts? Seems kind of strange. The reason is, though, let's say we're going to have a point at negative 3, 0. This point is saying something. It's saying that if we put on a negative 3 for x, then we'll get a 0 out for y. And the reason for that is if we take a negative 3 and we put it in here, negative 3 plus 3 will be 0. And since everything here is just multiplied together, right? This parentheses gets multiplied by this parentheses. You put a negative 3 in here, it goes to 0 times this, still is going to be 0. It doesn't matter what this is. And you're going to get a 0 out for the output, right? Let's just draw a table of values here. If for the x we put in a negative 3, negative 3 plus 3 is 0 times, it doesn't really matter what this is. Negative 3 plus 3 is 0. 0 times anything is 0. Same thing for 3. It doesn't really matter what this first parentheses winds up being. 3 minus 3, that's what you're going to get when you put 3 in here. 3 minus 3 will be 0, so 0 times, it doesn't matter, it will be 0. Okay, same thing over here. We get a point at 3, 0, because if we take a 3 and put it in for x, take a 3 and put it in here for x, then we'll get 3 minus 3 is 0 times, it doesn't really matter what this winds up being. We get 0 times whatever, 0 times anything, is 0. If we put in a negative 4, then we'll put it in here. Negative 4 minus 3, that's the first parentheses, times negative 4 plus 4. Okay, we'll get 0 here. Here we'll get negative 7, but it doesn't matter because we're multiplying it by a 0. So there we get a 0. Okay, so that's why intercept form works the way that it works, because those numbers that you're putting in to each of these parentheses causes them to go to 0, and then the whole thing gets multiplied together. Everything gets multiplied together, and part of what you're multiplying is a 0. And no matter what everything else comes out to be, once you multiply by 0, it's all over. It's just 0 forever. All right? Okay, now that's going to be more important, that you have an understanding of that multiplying by 0. Okay, so if you multiply a bunch of stuff together and one of those things was a 0, everything turns into a 0. All right? We're definitely going to go over that more So you'll gain a little more understanding as we go on. The last thing we need to do is be able to write things in standard form. Okay? And for that, we're going to address FOIL. Okay? I think you've probably heard of FOIL before. And at this level, I actually want you to not think about FOIL anymore. And I know it can be difficult, but it just, you know, it's like a level of maturity. We've just matured beyond FOIL, I think. Even though it is in the book, we're going to mature beyond it. And remember that the real key here is the distributive law. Okay, distributive law says if you have something multiplied by a parentheses that's adding or subtracting things together, you could do plus or minus there. You get A times B plus or minus A times C. You just multiply the A times everything in there. Okay, so what we just need to make sure to do is multiply everything in here by everything in here. So every piece, every little term in here needs to be multiplied by every term in here. And yes, FOIL will give you the exact same answer. I actually give the exact same answer in probably the exact same order as we're going to get it right now, except when we move on to something like x plus 2 times x squared plus 2x plus 3, now FOIL is absolutely obsolete. It does not work. Because FOIL is just a mnemonic device. It's just something that we keep in our heads to help us remember to do every step of what we need to do here. But FOIL will not do every step here. FOIL stands for first, inside, outside, last. Or first, outside, inside, last. And if you just do those steps, first, outside, inside, and last, you will miss some of the steps that you need to follow. So that's why I'm encouraging us to move away from FOIL and just think distributive law. So we'll distribute x to everything and then 4 to everything. So first we'll distribute x. We'll distribute it to the other x. X times x is going to be x squared. Okay, we'll keep distributing x. The next thing would be 3. That's going to be 3x. And that's over. X has been distributed to everything. Now you distribute 4. 4 is going to get distributed to x. 4 times x. 4 will get distributed to 3. That's 12. And 4 has nothing else to be distributed to. Okay? If you think of it that way, if you think everything in here needs to be distributed to everything here, you won't need FOIL anymore. It'll just be, you'll be one step closer to being a pure mathematician and just applying the laws, the distributive law. And here we have common terms, 3x and 4x, for a total of 7x. There we go. That is taking this guy here, which is in intercept form, and writing it in standard form. Let's do another one. We'll do one in vertex form now. F of x equals x plus 5 squared minus 2. I'm going to write this in standard form, which means we need to do something about this. Okay, here is a big pitfall for a lot of algebra students. What they want to do is something that's the easiest thing they can think of, which is, let's just take this 2 and we'll give it to that guy and that guy. X squared and 5 squared. No, that's not going to work. Okay, you have to follow what this 2 up here means. This 2 up here means what? Ask yourself what that means. If it were just 3 squared, what does it mean? What is this 2 telling us to do? It's telling us to take this number that this is above and multiply it by itself. Okay? That's exactly what it means here. It means take this, whatever this is above, and multiply it by itself. Multiply it by itself. Now this will give you a different answer from just taking this 2 and going x squared plus 5 squared. It's absolutely wrong. This will give you the correct answer. This is just like this guy up here. We want to distribute everything in here to everything in here. So let's grab a different color. You can distribute x to the first thing over here. That's another x, so x squared. Distribute the x over there. We'll get 5x. and x has been distributed to everything over here, and it's done. Now we'll take 5 and we'll distribute it to x. That'll be 5x. And take 5 and distribute it, continue to distribute it to the other 5, that's 25. And there's nothing left to distribute 5 to. And there's nothing left over here to distribute, and so everything's done. X squared plus 10x plus 25. So we should still have a minus 2. So x squared plus 10x plus 23. So now we've taken something in vertex form and written it in standard form. All right. If you have any questions at all, comment or email or whatever you need. Maybe I'll remake this video to make it make more sense. But that understanding why is vertex form so easy to derive the vertex? Why is it so easy to take the x-intercepts out of an intercept form equation? It would be very helpful for you to have an understanding of why. Okay, so ask questions to that end, to understand why. Thanks for watching.